Roofs shall not allow water to enter the structure or to pass beyond, around, or through any designed or actual moisture barriers.
This is just inside the front door of house 1. You can see clear evidence that there is a roof leak here in this location. It's damaged the paint and damaged the drywall. We're going to go onto the roof and see if we can determine the cause of the leak.
So here we're going to remove the roof sheathing above the location of the stain in the living room and try to figure out where the water intrusion is coming from.
What we found on this house is that there's a ceiling stain in the drywall just inside the front entrance. So we did a roof investigation to find the source of that water stain.
So in this location, which is near the source of the leak, you can see here that there's a lot of stains and water under the sheet metal valley right here.
And what we found in the valley is a couple of defects. The plywood is not nailed, and there's some high nails that put holes in the felt. And we looked underneath the sheet metal, valley metal, and what we found is that there's a missing component, and that's a bleeder's strip. You're supposed to take the felt, lay it in the valley before you do the field roofing, and then at the very end you put the sheet metal on top and then shingles. So the ceiling stain is in the drywall ceiling below this. This is a dryer vent termination, and we investigated a T-top over here, and the T-top is where we found a water stain in the roof side. But what we found is the stain in the drywall ceiling was occurring under the dryer vent exhaust. The leak, the water damage to the ceiling drywall correlates with the dryer vent. The cause of the leak and the damage to the ceiling in the inside the house is attributable to the dryer vent exhaust. There may be other damage resulting from the T-top vent. We found high nails, and the high nails we located before we took the felt off. We found the usual number of high nails that the carpenters leave that cause damage to the felt. Some wind damage where the shingles had been blown off by the wind. The magnitude of the stains suggests that there's more than condensation, that it's actually a roof leak. The stain extends quite a bit in the ceiling of the foyer. What we found here is that the insulation that's under the roof is not cut out for the attic vent, which means essentially that the attic is not vented as required by the code. I mean, there's a reason they spent money and they furnished and installed these vents. They have to ventilate the attic. But the insulation contractor ignored the vents, and they completely covered the vent.
So we're going to conduct a water test to take a look and see how the valleys are performing. You can see in this location that water traveled underneath the sheet metal valley. So you can see here in this location that there was prior stains on the roofing felt. Looks like there was some water ponding on the backside of the batten. There's a large amount of stains and water damage on the roofing surface. So here in this location you can see a lot of stains. And you can also see some stains on the edge down there, a little bit of water damage. In this location you can see the experts marking off some stains. There was obviously a lot of water ponding here at this edge metal. You can see the water was ponding there. It got onto the roof sheathing, it's damaged the roof sheathing, it stained it. You can see stains over here. It's getting underneath the tiles and traveling a good distance across the roofing felt. It's caused water damage to the battens here. And obviously if you have, here's another location right here, look at that. So obviously if you have any holes or cuts in the roofing felt from high nails and you're getting this amount of water traveling across the roofing felt, you're going to have a leak. You can see stains and water damage here. The drywall's damaged. There's a stain traveling from the edge of the entryway door several feet towards the window in the front of the house. Okay, so we are in the location directly above the stain in the living room. We're opening up a dormer in this location to see if we can see the source of the leak. I can already see some stains and water damage there. It looks like there's a lot of stains around the opening that was cut. You can see stains on the battens and stains on the felt. You can see some dry rot in the battens over here. You can see stains over here. There's stains at the top of the dormer location and running along the right-hand side. Here we have violation of Civil Code 896A4. In this location, you can see a number of high nails. In this location, you can see additional high framing nails. So here, the expert is marking high framing nails. Because the felt was short and not wrapped over the edge, it allowed water intrusion. So water got up under the felt right here because it wasn't long enough and wasn't wrapped around, and it got in and damaged the roofing surface right here. You can see the short felt there. It's a water entry point. Water has come in and damaged the roof sheathing. First course not nailed, second course not nailed, third course no nails. Here's another location on this roof where you can see there's loose tiles, not nailed. This tile's loose in the valley here. Tiles like this will block the water flow and interfere with the functioning of the valley. More loose tiles in the valley.
They're all too close to the valley. So those top two, those flashings actually overlap.
They're inside the valley.
The valley flashing, which is no good.
His landing to service the rooftop unit is not secured. It looks like it was just set on the roof, or if it
was. What's that?
There's no penetrations in the roof to hold it down.
Okay, so yeah, here's this ladder, not secured at all.
The last week, the homeowner had it hanging 3 feet off where the kids were playing. So lifting up right here.
All right, this is a shear wall. Studs, OSB, top plate, trusses are tied to the wall. The roof is tied to the wall with H1 clips. Now, the reason they call this a shear wall, the wind and earthquake forces want to shear the house on its foundation. That's why it's called a shear force, and this is a wall to resist the shear forces. It's attached to the foundation using special hold downs, and there's special nailing required at this wall. And the strength of the shear wall gets transferred into the roof, which then braces the rest of the house. All the walls in the house are attached to the roof, and it's a connection of the roof to the wall that distributes the strength of the shear wall into the structure as a whole. Now, if there's any weakness in the roof-to-wall connection, it'll translate in the form of damage to stucco in the form of cracks. And we do have some cracks here on this wall. So the shear wall is over here to my left. The cracks are here in front of me.
One of the distressing things about the stucco cracks observed are that these are significant cracks when in consideration of the age of the buildings. These buildings are not very old. They haven't had a lot of time to be subjected to high winds or even moderate earthquakes, but they're already manifesting cracks that are prototypical cracks of excessive flexing of the timber superstructure, which then means the superstructure was inadequately installed, cracking the material, and these cracks are going to continue to propagate, get wider as the buildings get older and are subjected to more and more loads. The problem is the building is moving back and forth, creating these cracks.
So the rigidity of the shear wall is not being transferred to the rest of the wall through the roof. Why is that? Well, let's look at the roof-to-wall connection. This is the roof diaphragm. It's the plywood or OSB sheathing. This is the truss, top plate, and back in here it's called a freeze block. This here is a block of wood between the trusses, the roof is supposed to be nailed to that, and that is supposed to be nailed to the top plate, and that is what provides a shear connection roof to wall. So the roof and the wall are required by code to be connected. This roof sheathing is supposed to be nailed every 6 inches to that freeze block up there. And that freeze block is supposed to be toenailed to the top plate. Now what we found in our inspection over here is another shear wall. And you'll notice up here that these nails from the roof sheathing to the freeze block have missed the freeze block. And we were able to stick paper there to make sure that there's no nails that substitute for the ones that were missed. So there's not a good connection between the roof sheathing and the freeze blocks, which means that there's not a good connection from the roof to the wall.
And you can see here there's a significant stucco crack here at the edge of the man door, right near the location of the defective roof-to-wall connection.
Engineers have told us that this does not substitute. This is a hold down that keeps wind from lifting the roof off of the wall.
These H1s are in wrong location. They should have been on the outside of the wall, holding down the rafter itself and not the joist.
These nails are what hold the truss down to the top plate, and yet all these nails are not in this piece of wood up here, they're just in this little scrap piece of wood. The point being that the roof and the wall are not well attached, which accounts for the fact that we have some cracks in the stucco walls. So we have consequential damage in the form of excess movement resulting from an inadequate roof-to-wall connection.
These posts are for the HDU2s, and this post, as you can tell, is split and compromised. All these big splits, especially right there where the hold down was anchored into the post itself. The post is split away, compromising the post itself, compromising the integrity.
All right, so on the second house, the strap's there, but it wasn't present on the first house?
No, sir.
Okay.
No, I did not notice them on the first house, but these were not over there.
Okay, that's
Okay.
interesting. All right.
This is all the way to the ground. You're supposed to leave a gap, but as you can tell, I can't even get my small little metal gauge. I can't even get it underneath anywhere. That's how tight the plywood is. Exterior type adhesive is on this side. So as it heats up, this will actually bond itself to the trusses.
Okay.
So not only is it the wrong sheet, it's backwards anyways.
So it's backwards and it's inverted.
Yes, sir.
All right, so these panels are installed in the wrong direction.
Those markings, they should be going left to right for vertical
Yeah,
walls.
so it should be flipped this way?
Yes, sir.
Okay.
On house one, this wall came all the way. Same exact house, same exact plan. This wall came all the way, and as you can see,
Here, it didn't.
it's two different ones. The other thing, this is roof sheeting. Same tag.
Okay, so it is the same panels.
Yes, sir. 2-inch lap of the weepscrete. Code states minimum 4 inches. Weepscrete's too low to the ground. Code clearly states bottom of the weepscrete is supposed to be 2 inches minimum from a hardscape.
You will see areas that appear to have been patched, and somebody will come along and try to fill the crack thinking that that's going to solve the problem. The real repair is removing stucco around it and reinforcing that corner since it already has exhibited damage. Patching stucco cracks is not a curative effort. It's purely just cosmetic. As you can see, there are a lot of occurrences of this, and this was very common, and this is just another example of lack of supervision, lack of quality control, lack of caring. When you see the variety of stucco thicknesses that we saw in this case, it clearly means that the stucco sub, his foreman, the project superintendent, contractor who signed an agreement with the city to build according to the building code, clearly didn't walk around and do any kind of quality control on these buildings.
Underdriven nail. Also overdriven.
Overdriven, underdriven, too close to the edge. They all contribute to reduction of that shear panel's ability to resist loads. The problem with air nails and staples is the same as any other structural component. It's intended to be, in this case, embedded into the lumber, because when you drive that nail and you don't hit the lumber, you know it, even with an air gun. You know, when you see a whole row of them like that, that just means the person installing the nails doesn't care, and there's no quality control.
It's incorrect nail size.
AD box, too small. Just like we saw on the roof. Way too small.
AD box, common with this construction. Nails are non-galvanized. Non-galvanized nails, causing rust and corrosion.
So here, the stucco contractor has effectively destroyed the window system. The purpose of the weep hole is to allow water to drain out from the window installation. Here it can't.
The exterior coach lights are not sealed properly to the wall. They didn't use standard materials for flashing that are available. They didn't use plaster rings. As a result, there are holes in the outside walls that allow rainwater to enter the stud cavities.
There were homes that had significant grading and drainage problems. Many homes had significant problems with the area drains installed by the developer. Large standing water in many of the properties.
Some of the shower heads were way too high, violating the building code. When the shower heads are installed above the protective surround, it violates the standard for installing drywall in wet areas. We found examples of splashback damage resulting from the fact that the shower heads were installed too high.
There were a number of locations where the shower heads were not properly sealed to the wall.
The installation of toilets is often left to apprentices and helper categories. Other resulting damage from a poor rough-in installation of the closet flange is the fact that the toilet is loose and it cannot maintain a caulk seal to the floor. Water can get under the toilet, floor covering gets damaged. Also, the baseboards can be damaged.
The defective installation of the plumbing fixtures will allow water intrusion into the wall cavity.
We have evidence of water getting underneath the sinks. We see corrosion of the porcelain sinks with a steel base. We see evidence of poor workmanship, rusting and corrosion where you have copper touching steel. This installation violates the code provision where the plumbing system shall not leak.
Generally, it was a defective installation of flooring in many locations throughout the home.
The nail pops and the cracks in the drywall are both damaging the paint. It's the responsibility of the drywall installer not to have the joints in the wallboard line up with corners in a ceiling. The natural stresses in the acting upon the ceiling want to cause it to crack. This is an example of drywaller installer negligence that has caused damage to the paint. Here we have poorly painted exterior trim where the paint is delaminating and blistering. We also see on this project examples of unpainted exterior wood. There's been substantial movement of the base cabinets relative to the backsplashes which are glued to the wall. That would be the fault of the cabinet installer. The base cabinets are loose, and these large joints are caused by the fact that the cabinets are moving and the joints are opening up. This would be the fault of the countertop installer.
Civil Code 896B1 provides that concrete shall not contain significant cracks or vertical displacement. You can see cracks in the concrete which have telescoped through, causing damage to the flooring materials. Tile work was damaged. Flooring was damaged. In this case, there were a large number of homes that had significant cracks in the concrete slabs.